Oh, great. We are just recording.
Yeah, I'm back. Sorry.
Okay, so you can take it up. The second part will be mine, and I will show you how to make some very simple research by using tools available on internet.
Okay, so let me share my screen. Okay, so I hope that you can read you can see the very first page of our presentation. Okay, so as we already said, the first part of this lecture will be on natural language processing in the legal domain. The two previous lectures given by Martin Hayek were on the quantitative analysis of textual data in sociology. And today we are moving to a different domain. We are moving to the legal domain. And the homework number 5 you did, it means the annotation of or subject labeling in a particular legal document, is a bridge to the legal domain. So I will evaluate your annotations, and then I will present you a real project, let's say, that is on information extraction from legal documents. So what was your task in the fifth homework? You were supposed to annotate subjects in a particular legal document. So the description of this annotation task is very short, and I think that the task itself is very clear. Our motivation to organize such annotation task was to first get experience with readability of legal text, and we will be speaking about it in details today, and then to evaluate an automatic system for syntactic analysis on a manually annotated data. Just as a reminder, here is a sentence: once a candidate country becomes a member state, it joins a legal structure that is based on the fundamental premise. This sentence is from the given European Union regulation, and 3 subjects are detected in this sentence. We selected the breadth editor to do annotation, and the instruction was to read carefully. We just focus on the preamble of the regulation. So read it carefully, sentence by sentence, and identify subjects in each sentence. In this task, we follow the Universal Dependencies Annotation Guidelines. I refer back to the lecture number 5, where Sylvia gave a very nice description or tutorial on this annotation framework. It means the Universal Dependency Framework. And she also introduce the UD pipe system for the automatic annotation following the Universal Dependencies Annotation Guidelines. And in this framework, a basic unit to process is a word, right? So following this annotation guideline, these annotation guidelines in our annotation task, you were supposed to label just one word. So subject is one word, or subject is exactly one word, and typically it is a noun. Oh, I'm very sorry for this noise. I hope that they will finish it very soon. So in this sentence, we can see noun, country as a subject, being a subject, pronoun, it, and pronoun sub, that. So this is just a reminder, what was your annotation task? We are heading for automatic subject labeling. So in other words, we want to formulate this task as a machine learning task. And I'm going back to my lecture on machine learning. And I describe machine learning as a triangle with 3 nodes. We have some real world objects. So in our task, we work with words in text. Then to process them automatically, we have to represent them somehow. In other words, we use some properties, features, attributes to describe real-world objects. And then we represent objects using feature vectors. Then this node in a triangle visualizes target values. In our task, we do classification. For each word, we are saying whether it is subject or not. So it is a binary classification task where just 2 target values, 0 and 1. And since we focus on supervised machine learning, we need to have examples or we call them gold data. In other words, we need to have a collection of text where the subjects are labeled. And that's exactly what you did in your homework number 5. So we selected the regulation, or the European Union regulation, and namely we selected its part, its preamble that contains 29 items. So what we have manually annotated subjects in the Czech, Polish, and French version of the regulation, and each version is annotated by 2 annotators. In other words, 6 students participated in this task, or they did this homework assignment. The regulation is available in 24 languages of the European Union, and we have annotated 3 of them. Here, just for illustration or for information, we can see the number of tokens in each language version. And this figure illustrates the breadth editor and subject annotation in this editor. We also process these 3 versions automatically using UDPipe. I really appreciate the work done by Jirka Mírovský. He processed actually all the versions, all the language versions of the regulation. As you can see in these figures, the UDPI system does a complex syntactic analysis. It means that it detects not only subjects, but all other functions, dependency relations. So it is a complex, it does a complex syntactic analysis of a text. So I'm happy that we have each version annotated by 2 annotators, because we can demonstrate the inter-annotator agreement. In other words, we are interested in the agreement between annotators. And I will illustrate it on the Czech version. We use the F measure, F1 measure, to compute pairwise inter-annotator annotator agreement. And then to compute this number for the given annotations, we have to create so-called confusion matrix. And again, I'm going back to my lecture on introduction to machine learning, and I explain confusion matrix in details there. And I describe it in the context of evaluation of an automatic system against the gold data, against the truth. But we can use it for measuring inter-annotator agreement as well. So two annotators of Czech version, A1 and A2. The annotator A1, the red one, labels 446 subjects in the document, and annotator A2 labeled 116 subjects in the document. We treat the annotator A1 as a gold standard and annotator A2 as a classifier. How to read this confusion matrix? So in the rows, we read the truth, so the true target values, and in the columns we read the classifier or the predicted values. So we can see that 113 subjects, well, these are so-called true positives. So the annotators agree on this amount of subjects. 33 true subjects were not recognized by annotator A2, and 3 non-subjects were recognized as subjects by annotator A2. To compute F1 measure, we need to compute the measure's precision and recall first. Recall is the ability of classifier to find all the subjects within a text. Right? So mathematically speaking, recall is the number of true positives, so subjects correctly classified, divided by the number of true positives plus the number of false negatives. And precision is the ability of classifier to identify only the subjects. So having these two numbers, we can compute its harmonic mean, so-called F1 measure. The range of this measure is between 0 and 1, And the higher the F1 measure, the more the annotators agree with each other. So here, for Czech annotators, we can observe rather high agreement. So in other words, we take the A1 annotator as a gold standard data and A2 as a classifier. We can, however, we can switch the roles so that the annotator A2 is treated as a gold standard and annotator A1 is treated as a classifier. Again, we can create a confusion matrix and compute F1 measure. And the resulting F1 measure is identical to the previous case. Thus, it doesn't matter which annotator plays which role, because the F1 measure between them will be the same. So I demonstrated to you how to compute the inter-annotator agreement for Czech annotators and how to measure it using the F1 measure. And here in this plot, we can see the inter-annotator agreement not only for the Czech annotators, or actually for the annotators annotating Czech version, but for Polish version and French version as well. I would say that I'm rather happy with the numbers I can see, and for sure we have to open the both versions, annotated versions, and to resolve the discrepancies between the annotators to get real gold data. And you can ask why the F1 measure for the French version is lower than for Polish and Czech version, but we haven't dived into the details yet, so I can not answer. I cannot answer the question. But maybe it is more difficult to detect subjects in French. I don't speak French, so it's just my hypothesis that it can be more difficult to detect subjects in French version. Yeah, I don't know. And having manually annotated data, we can evaluate the automatic procedure, UD pipe in this case. So for each pair of annotator and UD pipe, we can compute F1 measure as well. So here you can see 6 numbers saying how much a given annotator agrees with the with UD pipe. So here we can observe the highest agreement between the A2 annotator of Polish version and the lowest value for the French version by A1. And again, we have to open the annotated files and to see what was going there. I should also mention, and I hope that I'm right, that the UD pipe system is trained on the newspaper text only, on newspaper articles. And here we apply it to a text from a different domain. We did some experiments to test some other parsing system trained on newspaper text, and we tested on legal text, and its performance was not as good as on newspaper text, but it was a little bit lower because
Sorry, may I ask a question?
Sure.
These values, as for example for A1, in CS version, that means that it was treated as gold data.
Yeah,
when we have these values.
Yeah, the annotations by A1, by the annotator A1, were treated as a gold standard data set.
Yes, and the second column, A2, that means that it was switched, and it's the second case when A2 was treated as gold data.
Yeah, exactly,
okay.
Exactly.
Thank you.
Yeah. And once we resolve the discrepancies between A1 and A2, we will get a gold standard data that we then can use to evaluate UD pipe. And yeah, so we know that there are differences between newspaper text and legal documents, so we can expect that UDPI will not be, or its performance on legal text will not be as high as on the newspapers. But I just watching or observing this bar plot, I think that its performance it's rather good. It's rather good. Okay, so that's the homework number 5. I really appreciate the work you did, and I definitely we will use it, and we will think about training UD pipe only on subjects, right? So not to build a complete decision tree, but on to train on just to do simply subject labeling. We have some experience with processing of legal text, namely in the project of information extraction. In general, information extraction, it is a sub-area of natural language processing, and it extracts structured data from unstructured text by identifying, for example, entities and relations between them. And in the past, we addressed the project of information extraction from legal text. And namely, we extracted the entities related to the accounting domain and the relations of definition, right, and obligation. For illustration, in this sentence, accounting units shall take inventory of their assets and liabilities pursuant to section 29 and 30. So in this sentence, 4 entities are detected: accounting units, assets, and liabilities, and the relation of obligation is present. What accounting units have to do? Accounting unit has to take inventory. The legal domain for information extraction is really challenging because of the volume of data to be processed and its variety. Legal texts are specialized texts that operate in legal setting. They should be clear and precise. However, their style is generally considered difficult to read and understand. Typically, sentences are long and very complex and include long lists. So to do information extraction in the original text is almost possible. And therefore, we focus on answering research question whether we can do information extraction over dependency trees. In other words, we process or we annotate and input text with syntactic annotation, and then extract information from these dependency trees. Since there was no gold data for this task, we manually created a Czech legal text tree bank This collection is available in the Lindat repository. Here is its persistent identifier, and it is a collection of more than 1,000 sentences, manually annotated, and these sentences come from two Czech legal documents, namely from the Accounting Act and Decree on Double Entry Accounting for Undertakers. The manual annotation concerns morphological annotation. It means part of speech labeling and other morphological categories labeling. Then building dependency trees, so syntactical annotation. Then manual annotation of entities and relations between them. Here, just I illustrate you a dependency tree, or at least its part, for some sentence. And also you can see the annotation of entities, accounting units, and so on. The notes with the red background. And so the information extraction from trees is each relation is defined as a triple. What, for example, for the obligation, which entity has to do what? For example, in this sentence, accounting units has to create fixed items. And these triples are extracted by querying dependency trees. So both entities and relations are converted into tree queries. So here is the example of query, and matching this query with dependency tree so information extraction is realized as a matching of queries over the dependency trees. And I would like to conclude my part with a very short survey on subject annotation. Namely, I have two questions in my mind. First, how much time did you spend on the annotation task? And if you consider reading and understanding the text difficult. So if there are students who annotated the regulation, and if you are willing to share your experience with us, it would be great.
So if I can start, I think I spent on this task around, and I'm not sure because I don't remember it properly right now, but I think around 2 hours.
2 hours, okay.
And I hope that I didn't miss any part, because was it just that, sorry, one web page or where we supposed to go to next page and make more pages? Because I think it was just that one web page, right?
We are speaking about the annotation in BRAT.
Yes, yes.
Yeah, and there was just one document for each student. So
yes, okay. So that one document was right.
Just one document. Mm-hmm.
Yes. So around 2 hours, and I think that reading and understanding was quite difficult, because I mean that legal text usually consist of many. I'm not sure what's the right term for it, but it's not really verb, but it's adjective, but it has a similar function as verb in the sentence, if you know what I mean. For example, I had that check data set or check document. So I would like to say some example of check word, but not everybody would understand. So I mean, for example, fungující, zakládající se. That means that there is a lot of sentences, but it all refers just to one subject, and it's usually for many rows that you have one sentence and it has its beginning at one row, and then you need to go through 10 rows, and then there is eventually the end of that one sentence. So I think it's very, very complicated to understand it and concentrate on that kind of legal texts.
Yeah, long sentences are typical for legal documents, and sentences contain typically more than one clause, and so yeah, I do agree with you that it's not easy task, and we just focus on subjects. So you can imagine that building a complete tree for long sentences, it's really very difficult. We did it when we annotated Czech legal text tree bank, and we use different annotation tool, and we have to modify it a little bit because we would like to see these trees on our screen, and they are rather big, so we had to do some modifications. Okay, so thank you, Hannah. Thank you. And Ivan?
Yeah, I wrote it on the chat already, but yeah, I can say that I've completed my task within 30 minutes actually, and for me reading the text wasn't really difficult. But still, I've had one problem with it wasn't clear if we should. Was I supposed to like mark the subject of the dependent sentences, because like in Polish there can be more than one subject in one sentence, and I wasn't sure, should I just find the general subject or should like was I supposed to mark every dependent every subject in every dependent sentence? So yeah.
Yeah, so the answer is that each subject or every subject in the sentence. Here I have an example from the Polish version. So you can see, for example, this sentence number 33. Yeah, so there are four subjects. So subjects in each clause of the sentence.
Okay, I've just was confused by the instructions, because it strictly said that we were supposed to keep the universal dependencies annotation codex sort of, where each sentence has only one subject.
Okay, so it's misunderstanding. So we use the universal dependencies to say that the basic unit is a word, right? So subject has to be just one word.
Okay,
but
now I see.
So and definitely there can occur more than one subject in a sentence. Right?
Okay, so
if you are willing to finish your annotation, the BRAT is still open, and it's up to you. It's up to you if you are willing and if you have time.
Okay, I'll try and finish it later.
Okay. Thank you so much. And is there any student annotating French version? For if one of the two students? No, never mind. Okay, Anna, so we can move on to the part number 2.
Okay, thank you very much. So probably I will skip next slide, please, Bara. I will skip the general remarks because we will not have time to do the rest. So I will skip the why we need to have the readability, why it's important. I will skip why measuring is important, and I will just conclude that what we have. The next slide, Bara, please. I will conclude that we have quite an opportunity to compare readability of different language version in EU law. So that's what the reason why I've opted for European Union regulation, because it's available in all official languages of the European Union. So, and I opted for the preamble of the regulation because I thought that it might be a little bit easier reading for you than the real binding text of the regulation itself. So the preamble is more, as I feel it, more readable than the rest of the legal text. So what I have proposed here, next slide, is to look at these texts and compare them as to what language version is the most readable. And when I have dived into the question how to measure readability of European Union law, I have found the article of a Finnish scholar, Jukka Ruhonen, who did some research on 201 documents that are EU documents that are regulating the issue of single digital market. In fact, these documents, I have looked up what these documents are, and I must say that they are really of different kind. In these 201 documents, there are documents that are legally binding. You have the policy documents that are not legally binding. Within the legally binding documents, you have various types of documents in question. But what was important, that the regulations and directives and all documents related to single digital market are quite difficult ones. So it is not even for the lawyers difficult to understand what they are about, but also probably for the addressees themselves. The people who are dealing with the digital market, and they know all these technical aspects of it. And it was important for me how this scholar measures readability of law. And he's using 5 readability indices. And if you want to look at them, because I am not technical person, so I have not been able to understand what these technical readable indices are about. So you can click into the document and you will see his methodology. But what I did understood that the readability indices are related to the grade level of education. So the number, the score that is used is relevant towards the, or is related towards the level of the education achieved by the reader. So ninth grader would get score 9, about 9, and it means that the ninth grader would be able to read the text. So score 22 would be about for the university graduate. So as soon as you are university graduates, you will be able to score 22 according to this this scholar. So, and what he done, that he checked all 201 documents according to these 5 readability indices, and he concluded that the hypothetical grade to understand them would be around 30. So it's definitely more than to understand the legal EU documents on single digital market needs pretty much more than to be a university graduate. So the digital market legislation is a very difficult one. So I hope that the preamble was less demanding than the law on the single digital market that was analyzed by Ruohonen. So one thing that I would say this does not reflect this research is the difference in types of EU acts and documents. Because in my understanding as a lawyer, the documents that are not legally binding, so they are the policy documents, preparatory documents, should be a little bit easier to understand, so should be more readable than the EU acts itself. And also within the EU acts, you have different types of European Union acts. You have the regulations that are directly applicable. It means that are directed towards the, let's say, general public. Okay, even though they are very technical in the content, they are still, this is still a generally applicable act. So it doesn't require any transformation into national law, unlike, for example, the directives. Directives are typically addressed to the states and their administration. So I think that the presumption might be that the administration is able to read much more complex documents than the general public. So the criticism of the Ruohonen research might be that he had put all the documents into one group. So it might be better to more structure the research, the next type of research. So that's the way how it was done. The next slide, Bara, please.
Jana, may I interrupt you?
Yeah.
We should mention that he was working with documents, with English documents only. Am I right?
Yes, you are completely sorry for not mentioning it. So he just was working in one language version, and that's what I'm just now to just say, because we are going to present you what we have done to measure readability. And we have used the Quitup tool that is available, and you will see where, and compare it to the results of Ruohonen research. So to look whether the Quitup tool what it would show. The difference in both research is that Quitup tool deals with stilometry, so it measures the style, and the style in our understanding really helps better style, helps better readability. That's the presumption we have. On the other hand, Ruohonen have measured just the pure readability, so he had seen the readability in the context of the grade achieved by the reader. So this is the difference between the two approaches. And also what we have done while using Quitup, so this stylometry measuring, was that we have measured the all the language, some, not all the, but some language versions and compare them. So the Ruohonen approach is monolingual. So he just works with one, and this is the English version, English language version. And what we have done is a multilingual comparison. So Bara, the next one. Okay, so what's a Quitup? And maybe it would be, Bara, for you to present the Quitup, what it is.
Quitup is a procedure developed here in Prague in the Institute of Czech National Corpus at the Faculty of Arts. And it is a tool to measure style of text, and this procedure pre-processes input text using UD pipe. Right, so you are already familiar with this system, with this UD pipe system, and this system segments input sentences into smaller units, so-called tokens. So it does tokenization, then lemmatized text. In other words, replacing tokens with their basic forms, lemmas. Then it does part-of-speech tagging, so part-of-speech labeling and morphological categories labeling, and syntactic parsing. And since the collection of text annotating in the universal dependencies annotation guidelines is rather big, I think that the latest version definitely contains more than 150 collections in many languages. So then using Quitup, you can analyze, I am not saying any, or documents in any language, but definitely more language option is rather big.
Mm-hmm. Thank you very much. So the next one, please. Yeah.
So
okay, that's
okay.
yours.
Maybe I can just to understand well what we can measure using Quitup. I present you basic terms which I understand on the sentence. You cannot end a sentence with because is a conjunction. Right. So in total, after tokenization, we can see there, I don't know, I'm sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tokens. Quitup doesn't work with punctuation. In a standard tokenization procedure, punctuation is handled as a token, but Quitup doesn't work with punctuation. Then they work with token length. It is a number of characters for in a given token. So, for example, a token because contains, or its length is seven characters. They also count the number of word types, and it is a number of different tokens in a text. So in our sample sentence, there are 9 different word types. And they also work with function words and content words. Function words, they are called also as they are called, or semantic words. These words have little lexical meaning. For example, preposition, conjunction, pronouns, auxiliary verbs. So in our sentence, we can see there you, personal pronoun, preposition with, modal verb cannot. So these words, they actually they say nothing about the meaning of a text. On the other hand, content words or autosemantic words possess semantic content, and they are typically nouns, adjectives, most verbs, most adverbs, like sentence or conjunction in this sentence.
Okay, so let's look at the results of the research. Just to explain what I have done, I have took 1, 2, 3, 4, 5, 6 official language versions of the preamble itself. So the same text 6 of you have read. And I have made by simply copying and pasting a text document out of this, because the Quitup accepts only the text files. So you can see that at the end, you have here the 6 official languages of the European Union, but you have also here the Russian language. And how we have arrived to the Russian language is that we have used the tool for translation. So I've translated an English version by using a mechanical tool that is available at the UFAL, so at the Institute of I have used it to translate it into Russian. So what you see in light blue is the Russian automatic translation from English. Then the last, and this is the last column, that is called Winnie. In order to be able to compare it with a generally known text, I've chosen the text, the classics, English classics, by Mills, Winnie the Pooh. So I have took the same number of characters as in the English version of the whole preamble. It was about 17,000 of characters. And it took about first 1.5 chapter of Winnie the Pooh book. So I have put the book, I've made the text out of 1.5 chapter, and I've analyzed it alongside and compare it with the others. So each text was analyzed separately, because in Quitup you have to decide what language is the source language. So you can see the first measure that is here, and it's a number of tokens. Number of tokens is in fact a number of words. What we see that for the approximately the same number of documents, the same length of documents in terms of characters, there are disproportions. So, for example, the Russian, that is the automatic version, Polish and Czech, so the Slavic languages, have about the same number of tokens. On the other hand, you can see the disproportion between the Winnie the Pooh and English version of the preamble, because it is the question of length of the words. So the tokens, it basically amounts to words, are much more complex, are longer in the English version of the preamble than in the Winnie the Pooh book. So the next one, Bara, please. Next slide. Okay. So in the next slide, you would see how Quitup counted the number of different tokens. So you can again see that the Winnie the Pooh has a there is a slight difference in the length, in the number of different tokens. So because the Winnie the Pooh is addressed to children, it uses a smaller number of different words. So it's repeating the words much more often. So what is the striking difference is that the compared to the English version, for example, the official translation in Polish and in Czech is slightly different in terms of different in number of different tokens. So it would be interesting to analyze why these two languages are using much more, I would say, richer language in terms of the style than, for example, English. That is probably more technical, but it's just the supposition. It would need more insight into the reasons why these results are as they are. So next is the question of average token length, and it is not surprising that the average token length is smaller in case of Winnie the Pooh, that the author uses shorter words than in the authors of the European Union regulation preamble on the conditionality. So you would see that still there are slight differences, and what strikes me is the difference between Czech and Polish version, and the difference between the German and Czech and Italian version, for example. So it looks, as we say, for German, it's quite common that German uses much more complex and longer words. On the other hand, it doesn't explain why there is a difference between Czech and Polish. So I would say that it would be good to look into the way how these documents are translated in these two Slavic languages in order to see the reason why the average token, average word length is much more, is a little bit, not much more, but a little bit shorter in Czech than, for example, in Polish. So the next slide, please. Concerning the vocabulary richness. In vocabulary richness, and it's also not surprising if we compare Winnie the Pooh and the original English version of the regulation, we see there is a slight difference, because though Winnie the Pooh is a sort of bellatrix prose, that means that it would have more rich vocabulary. It is not the true, because it is addressed to children. So this vocabulary richness is a bit lower than in case of English version. But what you can see is the striking difference between the Slavonic languages, and especially the translation into Russian that was done automatically is in a striking difference between the English and French versions, official versions of the regulation. So that is the question why these Slavonic languages are more rich, and whether it does imply that they are less understandable in the text than the original English and French versions. But it's a good starting point for the research into the readability and comparison between the different versions, different language versions, because we see that there is a real difference in certain parameters. The next slide, please. Okay, the next slide shows so-called hapaxes. So it shows the words that are used just once in the text. And you can see, and this is quite understandable, that still the Winnie the Pooh is the one that has less hapaxes. It means it uses the same words in order to make it more readable for the children. In case of English difference, again, you can see that the difference between the official languages of the European Union, these 6 official languages, is still very high. And you see that the hapaxes are more often in the Polish and Czech version, what corresponds with the fact that the vocabulary richness was much more higher in case of these Slavonic languages. And of course, as we see, the translation, the mechanical translation into Russian is even has even less hapaxes than has more hapaxes than even the original English version from which it was made. So the next slide, please. And then we come to the question of what we call a function words. So how the text is descriptive, or how it shows the activity. So we measure here the activity by comparing the verbs and the verbs with adjectives, because the adjective shows that there is some activity in the text. And here you see that Winnie the Pooh has more these adjectives attached to a verb. It means that it's more active. The text shows more activity, and on the other hand, the texts of the regulation are more descriptive. And you see that here the adjectives are even less common in the Slavonic languages. So it would be interesting to think why, if we have more richness in the style, as we proved before, why we have less activity in the same text. So why there are less adjectives in the translation, official translation. Okay, the next one. And the last is the thematic concentration. So Bara, if you can say a few words about what is it.
Okay, sure. Let me get back to the previous slide. We are speaking about content words. Just clarification that the title it's not correct, because we are speaking about verbs and adjectives. So we are speaking about content words, and yeah, so it is just clarification because we paid attention to explain Quitup terminology, and here is our mistake. So I'm sorry about that. Thematic concentration. It is so we the measures presented so far focus on the counts of tokens, counts of content words and so on, so on. And here the measure called thematic concentration focus on the frequencies of word types and on the ranks of word types in the list of word types ordered according to their frequency. So in other words, what we do, for each word type, we count its frequency in the document, and we rank the word types decreasingly according to their frequencies decreasingly. Right? So we have then we get a list where the most frequent word type is on the first position, and so on, so on. In total, the length of this list corresponds to the number of word types in the document, and the frequency of this word type is greater than frequency of the second word, and so on and so on. And at some point, we, based on the ranks and on the frequency, we split the list, and the part or word types above this line, it is a function branch, and below this line, it is a content branch. So for sure, in this part above the line, we observe more function words. Right? Typically, frequency of conjunctions and prepositions are higher than frequencies of content words in general. But it can happen that in this part, we observe some content words. And Quitup consider these words thematic words. And the occurrence of the content words in this part is understood as a kind of anomaly caused by the importance of the word type in a text. So in other words, thematic concentration can be interpreted as the writer's effort to communicate some topic more intensely than other topics, and topics are represented by thematic words, right? And I think that this plot is perfectly in line with vocabulary richness we observe we already observed.
Well, I just have, the doubts, because if you look at the vocabulary richness slide, the difference between the German and for example, Czech is not as I would say as obvious as we have in the case of the thematic concentration. So
yeah,
do you have some idea why it should be? Because still we have to think that this is the same text. This is the same legal text, and it looks that the Czech text is more concentrated on the main topic, and the German is not. So it's quite striking that there is such a difference.
But we are focusing on vocabulary actually used in the language versions. For illustration, here I provide to you a list of the Czech words and English words with the highest thematic concentration. And we can see that the values for Czech words are higher than for English words. For the values for the given words are highest than for the English words, and so this value is computed, or the formula computing this value includes the frequency of word type and its rank in the list here in this list. And my explanation is that in Czech version, more attention is paid to word selection, or I would say, I don't want to say that the Czech translation is more precise, because it doesn't make sense, but the vocabulary is richer than English. Yeah. And the frequency of content words in general, or not in general, but at least for the words in this list, is in Czech version is higher than in English version.
Okay, thank you very much for this explanation, but I still have to make up what it proves for me as a lawyer. You know, lawyer would say that the Czech translation more speaks about the union and English translation more about the law. So that what would lawyer make up from this? Okay, so that's.
But you can see there is a Czech adjective právního, legal. We can say legal, and its thematic concentration is higher than the word of than the thematic concentration of law in English.
Right. Right. Yeah, that's right. Yeah. Okay. Yeah.
May I also add something?
Yeah.
I think that you can't compare these scores across languages. That you can only compare texts within one language, since there would be English texts in general can appear less thematically concentrated than Czech texts, because English might have, simply by its grammar, more function words everywhere than Czech. Just imagine all the articles and so you would have to somehow normalize it.
Yeah, Sylvia, you are right, and we have to discuss in more details where to cut this list. And it is a rather fuzzy decision boundary, but between function words and content words, right? So yeah, this is just an idea what we are working with, but to interpret these numbers mathematically and with respect to some statistical significance, we definitely dive into details, and in more details into the formula for thematic concentration computation.
Okay, but my initial intention while doing this very simple research was just to exactly what you said, Sylvia, to see whether we can compare the languages or we cannot. So whether the readability is maybe the next slide, Bara, and we come conclusion whether the readability is language specific, and that's the same conclusion you have reached, Sylvia. So that's that we have to look at the readability always in certain language. So even if in theory all languages of the European Union have some legal value, the counting or the measuring the readability of a language always relates to a specific language. So it really shows that these measures are very much variable if we compare the languages, several languages of the EU. So that's the first conclusion, that when we decide about or when we measure readability, we have to do it in one language, because there are quite significant differences with respect to various languages. And of course, we have to measure readability of legal documents by reflecting what type of documents we are talking about. So if we measure, for example, readability of European Union law, we have to measure separately the regulations that are general applicable rules, directives that are addressed to states, and even in case of decisions that are individual acts, we have to distinguish between the decisions that are addressed to states and those that are addressed to non-state entities, so to physical and natural and legal persons. So that's next conclusion. And the last one, and that's what came to me from the Finnish research, that the readability of legal documents should be somehow defined by using something like an average user. So we have to see, for example, that the accountancy legislation or single digital market legislation are addressed, even that are all directly applicable rules, they are addressed to different users. Okay, accountancy legislation is not used to is not addressed to general public, but it would be in fact, not in law, but in fact used only by accountants. The same thing is with the single digital market legislation. It would be used by technical people who would look it up. That's the case, Sylvia, we have discussed during my class, the directive we have then discussed. So that's a specific type of users. On the other hand, if you have a criminal code, or if you have a labor law, labor code, this is addressed to I would say, average people, that you cannot suppose that they have all university degree. So that's something that you have to take into account while drafting that sort of legislation. So my conclusion from this short research is that we could work with these tools while assessing readability of legal documents, but we have to do it carefully, and we have to take into account the type of legislation, type of document in question. So if you have any other comments, I would be quite happy to hear them, or questions. And just if you are interested, I have some further reading for you. So you have here the content of important articles, the basic articles of Jukka Ruohonen, and also the article that is not exactly the most recent, of Hilary Fruman, that speaks about the lawyers and how they care about readability. And you may know why they are not caring about readability. So what are the reasons why law is such difficult to read? And last but not least, if you don't like reading, you can, and you speak Czech, you can listen to the lecture Lara and me and myself had some 2 years ago during the event that publicizes the results of our research, and it speaks about how the artificial intelligence understands civil code. So that, but this is just for the Czech-speaking participants. So thank you very much. That's all for me, and I am waiting for questions, comments, complaints, or whatever you may have.
Okay, so as there was that research by Jukka Ruhonen, there was some grade level, like hypothetical 30 of readability. And I would like to know if it was calculated by some formula, like mathematical formula, or
exactly, it was. That's why I didn't mention it, because that's exactly the reason why I went studying law, because I don't understand the math. So I skipped it, but if you look into the article itself, it does contain a formula. So you have to, so it's not a in the form of an active. So I maybe give it into the chat as a sort of clickable. I have to look it up. So just give me a minute and you will have it. Okay. In the meantime, some other questions?
Maybe I could just comment on the readability formulas, just to anticipate that you are going to be surprised how primitive features they take into account. It's the classic formulas that Ruhonen uses there. They actually all use the length of sentences in number of tokens, and the length of tokens in either a number of characters or a number of syllables. And it looks really crude, but it isn't. The first of these important classic formulas was flash reading ease. And this person, Rudolf Flesch, was first experimenting with much more linguistically informed features, which were and it was in the 1930s. He was working for a publishing house and was paid for finding out how to raise the subscription numbers for the journals and magazines. The publishing house was selling, and so he went with pen and paper and extracted various linguistic features. At that time, it was impossible to extract this automatically. So he wanted, and he found something, but it wasn't usable for in large scale, like to manage quality of the production of the house. So he was looking for something primitive enough to be extracted automatically or very quickly manually, and he found, and he was looking for strong correlations with those linguistically informed features. And luckily, it was the length of tokens and length of sentences. So you get from very complex things back to very simple things that you couldn't have known before.
So it's division of those two, or
it's more complicated than that.
I'll look at it later.
No. It's not much complicated. If you just Google flash reading ease, you'll find out that there are some coefficients it's some ratio of length and blah blah tokens and sentences with some coefficients. There's not much more to it. And I would also like to say that this formula, this was the sort of first one, and the one taking returning you the school grades, that's probably the Flesch-Kincaid formula or RE, the other ones, most of them try to give you the number of years you would have gone to school to understand this text in terms of American school grade system. In terms of American 1940s school grade system, and and so to return back to the main point, this is language dependent. It's all done. It was first all done for English, and when you apply these English coefficients on other languages, it would also measure something, and very likely the ranking would be okay. Like what you think is easy would also look easy, and what you think is difficult would look difficult, but it would be on completely crazy scales. Like the Flesch reading ease goes from 0 to 100. The bigger the number, the easier it is, because it's the ease that grows somehow counterintuitively, and if you and to get Czech or German or whatever language on the same scale, you have to adjust the coefficients. And I don't know how it was done before machine learning, but now it's done on parallel corpora. When you have enough parallel texts, then you can have a very strong assumption on the texts being readable have the same level of readability approximately, and then you fit the function for English to the function you get for Czech, and that gives you the Czech or the other language dependent coefficients. So if you are interested, you can ask me more about it. My graduate student did that for Czech.
Okay, thank you very much. So
no problem.
As we used the tool Voyant from Mr. Hayek, I guess, for our homework with migrant stories, there was also some function calculating readability. So it was write this this way down, or
yeah, it was very likely it was the English one.
Yes. So I need for every single language different coefficient.
Or you cannot. You would be able to rank your texts even if you use the English formulas, but you wouldn't. When it says 30, then you cannot be sure that it's the English 30. Like Czech texts, all Czech texts look absolutely crazily complicated in terms of the English formula. You even get negative numbers. Like you get completely outside the scale.
Okay, thank you very much.
No problem.
Later.
Okay, I would just add that for the Polish-speaking participants, I have added into the chat the jasnopis.pl. That's a tool that allows for simplifying Polish text. And in fact, what I have done just to use it and look how it works, that I have pasted the Winnie the Pooh text, and I got a level 1. So it was said, there was a short comment that it's childishly easy to read. And then I have put the part of the preamble of the regulation, and it got, I think, level 7 out of 9. So it was pretty high, difficult to read according to this tool. So both is available for Polish language only. So, okay. So thank you very much. It's all from me. I don't know whether there are some announcements or other informations concerning the next classes. No? Okay, if not, thank you very much for today, and I'm looking forward to see you in Prague during our workshop. So have a nice day.
Have a nice day too.